So we're going to do the second part of writing equations of parallel and perpendicular lines, which is section 4.3, and we're going to talk about perpendicular lines. So first, let's define what are perpendicular lines. Well, perpendicular lines are lines that intersect to create 90-degree angles. Okay, remember 90-degree angles are also known as right angles. So if the two lines or more intersect to create 90-degree angles, then those lines are what we call perpendicular. Now, how do we tell that in an equation? Well, they have a specific type of slope. The slopes are what we call opposite reciprocals. Okay, so you might be thinking, well, what are opposite reciprocals? When we think opposite, you think opposite sign, and reciprocal means to flip the fraction. So for example, 2 and -1/2 are opposite reciprocals. All right, something like -1/8 and 8, or -2/5 and +5 seconds. Those are what we call opposite reciprocals. If you're not sure if they're opposite reciprocals, they should multiply to make -1. And that's always a way to double check. So for example, this 2 times -1/2 will end up becoming -1. All right? So if we take a look at the first example, I want you to figure out if the lines are parallel or perpendicular and explain how you know. And remember, what do we know about parallel lines? Well, remember, they have the same slope. Perpendicular, again, are opposite reciprocals. So what's really important is we need to look for what kind of slopes we have and then compare. Are they the same? Are they different? And if they're different, are they in particular opposite reciprocals? Remember, if they have the same slope, we also need to double check that the y-intercepts are different. All right, I'm going to go ahead and scroll on up. And the first thing I want to do is I want to go ahead and find the slope of each line. So I've got line A, B, and C. So the slope of A, which I can calculate using either rise over run or using my slope formula, should be up 1, 2, 3, and over 1, 2. So that's going to be 3 over 2, right? For line B, I can, again, count rise over run, or I can use the 2 points, right, and do y2 minus y1 over x2 minus x1. I'm going to go ahead and count, but I'm going to go down 1, 2, and over 1, 2, 3, 4. So that's -2 over 4, which is the same thing as -1/2. And then finally, I'm going to check out C. So C is this one over here. And again, I can count rise over run, or I can do my point slope or slope formula. So I'm going to go up 1, 2, 3, 4, 5 over 1, 2, 3. So that's going to be 5/3. And then we'll see that none of these slopes are either the same or have opposite reciprocals. They're all just different, no special relationship, so no lines are parallel or perpendicular. And then you want to make sure you explain why. So we're going to say because no slopes are the same or opposite reciprocals. Okay? Taking a look at B, we want to do the same thing. And just like in the last set of notes, when we did parallel, we want to identify the slope. So what we can do with equations is we can go ahead and solve for y and get y equals mx plus b. So for line A, the slope is already pretty easy to see. It's what's in front of x because we have y equals mx plus b, and that's 2/3, right? For line B, we have 3x plus 2y equals 8. So what I want to do is I want to solve for y. Divide everything by 2. So I get y equals -3 over 2, x plus 4. So the slope of B is -3 over 2. And then finally line C is 3y minus 2x equals -9. I'm going to take away 3y from both sides. Oh, I'm sorry. I don't need to solve for x. What am I doing? I need to solve for y. So I'm going to go ahead and add 2x to both sides. And then get 2x minus 9. Divide everything by 3. to get y equals 2/3 x minus 3. And again, all we want to do is we want to take a look at that slope. So the slope of c is 2/3. So when I compare these numbers, I might say, hey, look, 2/3 and 2/3 are the same thing. So A and C are parallel. Because the slopes are the same. And if you look, those y-intercepts, 3 and -3, are different. And then something else I'm going to notice is, look at this slope for b. It's -3/2. Well, that's the opposite reciprocal of 2/3, because 2/3 times -3/2 equals -1. So that means b is perpendicular to both a and c. So you can either say that they multiply to -1 or tell me that they're opposite reciprocals. Either one would be fine. Okay? So again, we want to focus on slope. If they're the same, also take a look at the y-intercept. And if the slopes are different, just double check, do they multiply to -1? Are they opposite reciprocals? So if we take a look at the u try 1 and 2, I just totally noticed I made a mistake. I forgot to write the word perpendicular in there. So we want the same direction. So determine which of the lines are parallel or perpendicular. Let's just add that in. I can't fit that in. All right. And then tell me why. So just like I did up here with A and B, right? It could be none. It could be a combination of both parallel and perpendicular. It could just be one or the other. So take a look at 1, 2, find those slopes for me, and let's see what we get. So go ahead and check your work. I'm going to check the slopes for 1, check your equations and your slopes for 2, and then look at your explanations. So since we know 3/2 and -2/3 are opposite reciprocals, right? We are flipped and have opposite signs. They multiply to -1. They are perpendicular. And then for number 2, this is similar to B from above. Since 3 and -1/3 are opposite reciprocals, lines A and B and also A and C are perpendicular, right? And then B and C are both have the slope of 3, so they are parallel. All right, so we're going to go ahead and stop here. We're going to write the equations of perpendicular lines together in class, but please come back with questions. Thanks for listening.